So, real world applications of a parabola or the quadratic equations. So, we are going to demonstrate a real world example application and then solve one question using the real world scenario here. So, this is a cannon and a cannonball. So, typically a cannon is used to release cannonballs. So, if we were to, let's try to release some cannonballs and see the motion or the path in which the cannon traverses. So we see that it traverses in a whose equation is like a quadratic equation. So again, let us try one more. So this time it's a different kind of a trajectory, but yet the motion is like a parabola. Now we can also change the cannon's angle and then fire some and see where it happens. So again we see that the cannon releases cannonballs whose motion is a parabolic motion or a quadratic equation. So what we are going to do is we are going to actually define one question using this one and then see what we get. So we are going to basically, we have written a question based on this application here on the whiteboard, which says that the height h of the cannon that traverses is given as 15 by 2t minus 5t square plus k, where t is the time. That means at any given time t, the height h is given by this equation. Similarly, the horizontal distance traversed by the cannon is given by a second equation, x is equal to 15 root 3 by 2t. The question asks us to find the maximum height the cannonball reaches and the horizontal distance it traverses. So let us try to draw this picture once again. So remember that we have the cannon is at a height of 4. So it is at height of 4, and then the cannon balls that are released are following the shape of a parabola. So here. So that means at some point it will reach a maximum height. So this, let us call it as capital H, because this is what we're going to find. Now the height of the cannon, you can see that in the diagram it is 4 meters. That means the cannon is releasing the cannonball from a height of 4 meters. So that means that this point is actually a point on the parabola, and you can say that this is 4. That means the height is given as 4. So we are also asked to find the horizontal distance. That means this length where the cannonball reaches the ground. Let's call this as d, the horizontal distance. So we need to find these two values, h and d. So first thing is, let us write the equation that was given here. So we are given h equal to 15 by 2t minus 5t square plus k. So the equation is not completely defined because k is unknown, and first we have to find k. So for that, what we can do is at time t equal to 0, the cannonball's height is 4 because it is getting released from the height of 4. So we can substitute these values and we will get k equal to 4. So now we can write our equation is 15 by 2t minus 5t square plus 4. So this is the equation of the cannonball's path. Now what we have to do is we have to find the maximum height h. Remember that for finding the vertex point, because that is the maximum point, we typically use a binomial square technique. That means we will try to create this as a perfect square. So what we'll do first, let us rearrange some terms here so that t square is the first term, and then we'll go from trying to solve this one in this fashion. So we'll take minus 5 common, and then this becomes t square minus 3 by t 2e plus 4. Now to make it a perfect square, we need to add and subtract some terms. So let us try to see which term we can add. So if we have to add 3 by 4 square and then therefore we also have to add 5 times 3 by 4 square, and then plus 4 is as is. So now let us try to simplify this equation as h equal to minus 5 into t minus 3 by 4 square, and this will be 5 times 9 by 16 plus 4. So the final equation is minus 5 into t minus 3 by 4 square plus 16 fours is 64 and 45 is 109 by 16. So let us divide 109 divided by 16. So this is 6.81. So let us try to write it in a compact form, that h is minus 5 into t minus 3 by 4 square plus 6.81. So this equation looks like minus a into x minus h square plus k, where h and k are the vertex. So comparing this one, we can now write our vertex is 3 by 4 for the x coordinate and 6.81 for the y, and 6.81 is what we want because the maximum height is 6.81. Let's go back to the diagram we draw here. So we see that this h is 6.81. So we get h equal to 6.81. Now we need to find out d. So in order to find out d, what we have to do is we have to use the second equation. So what do we see in the second equation is x is 15 root 3 by 2. So it is 15 root 3 by 2 times t. So we have a t unknown, that means we have to find t. So remember that in this parabola, when the height is 0, it touches the ground. Therefore we can find by setting h in the first equation h equal to 0. So we set h equal to 0 to find the t value. So in this minus 5 into t minus 3 by 4 square plus 6.81. So we put h equal to 0 because the cannonball's height will be 0 when it touches the ground. Now we can find out how much time it traverses to reach the ground again. So let us move some equations here. So t minus 3 by 4 square equal to 6.81. So we will get t equal to 3 by 4 plus or minus the square root of 6.81 by 5. So let us write this as 0.75 plus minus, let us calculate what is the square root. So 6.81 divided by 5 and taking the square root gives us 1.16. So it is 1.16. So we will take only the positive value of t because the negative value of t is not meaningful for our problem here. So it will be 1.16 plus 0.75. So we get 1.91. So we got the time t it takes to traverse is 1.91. Now x is the horizontal distance. Now we can substitute for that into t is 1.91. So let us try to calculate using the calculator. 15 into root 3 is 1.732, and then we divide by 2 and then we multiply by 1.91. So we get 24.8. So the whole value is 24.8. So what we got is the horizontal distance d is 24.8. So let us check our diagram here. So we got here 24.8. So what we are trying to say is the cannonball hits the ground at 24.8. It reaches a height of 6.81. Now let us go back and check our figure where we can release some cannonballs and see what happens. So now actually let us try to release some cannonballs. So okay, so we should, because our speed is 15, we should put it 15 for the equation here. Okay, let us erase this one into, so let us try to do. Okay, so this is the distance it traverses and the height. So how do we find out the height? So here we have a scale here, so we will use a scale to measure. This is a real world simulation, so these all the values here are correct if we can measure it correctly, because these are properly scaled. Now we are going to set it approximately, so it is coming 6.81. I think if we put it correctly we will get, yeah, so we see that our height is 6.81. so this is the maximum height the cannonball reached, and the horizontal distance, actually we already see the 24.8, but let us use our scale to make sure that is indeed 24.8. so let us mark this one properly here, and then I'll drag this one to, and you can see that it's